So hi guys, before we start the video, I just want to let you know that this is a practice one. So if you do want to attempt the question before I do it, then pause the video. So I'll be leaving timestamps on I'm doing 3 examples and I'll leave timestamps in the description of when they come up. So you can skip to them and then you can pause the video when you see the question that's shown up before I attempt it. And then you can check alongside me while I do it. So yeah, enjoy the video. So hi guys. So in the last video, we were exploring what exactly permutations and combinations were, and we were introduced to them. In this video, we're going to be going over some exam-style questions on permutations and combinations that you might expect to get in the additional math exam. And we're going to be approaching them in different ways, because oftentimes for these questions there are multiple ways of approaching them, but it's about being smart with the ways that you choose, because some of them are more time effective than others. So from a group of 7 men and 6 women, 5 people are to be selected to form a committee, so that at least 3 men are there in the committee. In how many ways can it be done? So we have to first identify, is it permutations or combinations? So clearly we can see that the order in which the people are chosen does not matter. It's just 5 people. It can be person A, then person B, then person C, then person D, then person E, or the other way around. It really does not matter. So this is let me just write down, combinations question, which means we're using NCR. Let me just edit that right there. NCR. And if we recall, N is the number of items, which in this case is 5. And in this case is 13, because we're choosing from 13 different things over here. And R in this case is 5. But that's not actually that simple, because if we were doing that, that would just be choosing 5 people from 13. But we actually need at least 3 men here, so it throws a little bit of twist in there. So what we need to do is find the different ways in which we can organize the data. So we can first see maybe if there are 7 men and if there are 5 men and 0 women, or 4 men and 1 woman, and 3 men and 2 women. We can go about it like that. We could do it where we choose 5 men, then 4 men, then 3 men, or we could do it another way, but I'll show you that after we use this method first. So the ways, so basically we just can't have less than 3 men. We can't have 2 men, 1 man, or 0 men. So the first thing we do is see how many combinations are there with 5 men and 0 women. Well, that would be 7C5, because we're taking it from the 7 men over here, times 6C0, because we're choosing no women. If you check on the calculator, 6C0 is actually just 1, because there's only one way you can choose nothing, which means it's just 7C5, which is equal to, so let's just do it on our calculator right here and calculate it. So with the TI-30XB calculator, let's do it. So we do 7C, we click the 2, 5, which gives us 21. So that means that in this instance, 7C5 is 21. So to get 5 men and no women, there are 21 different instances, because we're essentially just choosing 5 men from 5 of the 7 men in there, and there are 21 ways of doing that. Now, we have to find the different ways where there are 4 men and 1 woman. So that's 7C4, because we're choosing 4 men from 7, times 6C1. Now, if we evaluate these separately, we can see that, let's just do it right now. So we have 7C4, which is 35, and then we multiply that by 6C1, which gives us 210. So in this case, our answer is 210 when we're choosing 4 men and 1 woman. Well, you might be wondering, why are we multiplying it here and here? Why aren't we adding it or whatnot? Well, that's just because they're in one scenario. When you choose 5 men, at the same time you're also choosing 0 women. When you're choosing 4 men, at the same time you're also choosing 1 woman. And therefore, because they're part of the same scenario, they have to be multiplied together. I'll show you some more examples where they get added instead. Okay, so we've done this one and we've done this one. Now let's do the one where there are 3 men and 2 women chosen. So that's 7C3 times 6C2. Let's just evaluate that on our calculator. So we do 7C3, which is 35, times 6C2. That's 525. So now we have to just add up all these instances. Now, here you might be wondering, why are we adding up 21 and 210 and 525? Well, it's because they're part of different scenarios. They're not part of the same combinations. So, essentially, we are just adding them up because we could be choosing 5 men, but we're not choosing 4 men at the same time. We're just choosing 5 men. So they're completely independent of each other. So let's find the total number of scenarios. Remember, we're not doing it with 2 men and 3 women because then that violates the criteria over here of 3 men. So 21 plus 210 plus 525 is, let me just do it on my calculator, but you can just do it in your head if you want, 756. So the answer to this question is 756 different combinations. Okay, so there is actually another way that you can do this problem. It's a little bit more time consuming in this instance, but sometimes it's more advantageous, and I use it a lot in my papers. So we got 756, but there is another way of getting that answer. We can actually just take the total number of combinations, like without the restriction of 3 men, and we might subtract it from all those instances that don't work, namely the ones where there are 2 men, 1 man, and 0 men, like that. These instances, in this case, subtracted from the total number of combinations would give us 756. So let's just try that real quick. So we have the total number of combinations. Since there are 13 people in total, 7 plus 6 is 13, and you choose 5 people. 13C5, let me just write it down, is, on our calculator, let's just do it real quick. Okay. 13C5, that's 1287. So there are 1287 total combinations with this example where there are no restrictions, like no restrictions on number of men and all that. Now, we can look at the number of instances where there are 2 men. So that would be 7 choose 2 times 6 choose 3, which is equal to, let's just do that real quick, 7 choose 2, that's 21. Then we can multiply by 6 choose 3, which is 420. So, where there are 2 men and 3 women, there are 420 different examples. Now, let's do it for 1 man and 4 women. That's 7C1 times 6C4, which is equal to, let's do that real quick, 7C1 times 6C4. So that's 7 times, okay, so it gives us 105. So, in this instance, it's 105. And let's do it for the last example where there's 7C0, there's 0 men in total, times 6C5, which is the same as 6C5 because this is essentially just 1. So that's equal to, let's just do 6C5 real quick. 6C5. That gives us 6. So, we've got all the instances where it doesn't work. Now we just subtract it from 1287. So 1287 minus 420 minus 105 minus 6 is equal to, let's just do it on the calculator just to be sure. 1287 minus 420 minus 105 minus 6. That gives us 756. So both these methods, they both gave the same answer. Therefore, both these methods work. And that's just another way you can approach it. In this instance, it would be a bit longer because you also have to find this value. But in some of the other ones where they ask you, for example, to say the one where there are at least 4 men, that means that there would be more, like there would be less things to do. You'd only have to calculate the one where there are, if they ask you to say if there are at least 2 men, then you'd only have to calculate that instances where there's only 1 man and 0 men. Or if they ask you to calculate when there's at least 1 man, then there's only one instance where you have to calculate and subtract from the total amount, which is the instance where there are no men. So you can look at it backwards like that, or you can do it normally. Either way, it gives you the same answer. It's just more time efficient one way or the other. So that was problem number 1. Let's look at the next problem. You need to put your reindeer, Lancer, Glupin, Rudy, and Bluepin in a single file line to pull your sleigh. Glupin and Rudy must be together. What are the total number of arrangements? So the first thing we must consider is this a permutations or combinations question? In this case, we can definitely say that it's a permutations question because it does matter their order. For example, putting Lancer here, then Glupin here, then Rudy here, then Bluepin here will be different from putting Lancer here, then Glupin here, then Bluepin here, then Rudy here. They need to be in a specific order, and thus it's permutations. So I've already kind of just outlined what the letters are. So for Lancer, it would be L, Glupin will be G, Rudy will be R, Bluepin will be B. That way it'll be much easier to refer to them rather than having to write their whole name the entire time. And let's just draw our diagram, the simple 4-box diagram. Because in permutations, this is the most useful thing you can do when there's a specific order. So well, you might be wondering, why can't we just do 4P4? Because there are 4 reindeer and we have to arrange them differently. Well, we can't because there's a condition. Glupin and Rudy, they must be together. And 4P4 would have the permutations where Glupin and Rudy could be on either side of the thing. They could be here and here, but that wouldn't work, would it? So the thing we need to do is, since Glupin and Rudy are together, we need to put them as one unit. So let's just reserve these 2 boxes for Glupin and Rudy, and let's make them 1 unit. So this is no longer 2 things. Now we have actually 3 things to consider because we've just merged one together to make Glupin and Rudy. Glupin and Rudy are in this box because they must be together. So now we have 3 things, and we can really order them with the permutations thing we see here. So the thing would be 3P3, or we could also consider it with our diagram, which is now 3 boxes long. So there are 3 different possibilities for who can go here. It can be either the combined unit of Glupin and Rudy, Lancer, or it can be Bluepin. So there are 3 different possibilities. Now we put one of the reindeer here. There are only 2 left for this box and then 1 left for this one, which is the same as 3 factorial, which is equal to 6 different combinations because it's 3 times 2 times 1. So there's 6 permutations, actually, not combinations. 6 different permutations for this example. But that's not all. We're not done here. It's not just 6, because while Glupin and Rudy are 1 unit and they're 1 box, what if, let's just enlarge this box here, this big box with Glupin and Rudy, and where we have 2 slots. So one example could be Glupin here and Rudy here. Another example could be Rudy here and Glupin here. And no, we cannot just add 1 more instance. We have to multiply it by 2, because this could be the same thing if this box was moved here or if it was moved here. Whatever the case is, it's in the same scenario, so you have to multiply it. So the answer would actually be 3 factorial from arranging Glupin and Rudy as a combined unit with the other reindeer times 2, because Glupin and Rudy could be switched around in their little unit, which is the same as 6 times 2, which is equal to 12 different permutations and orderings of the reindeer. Of course, you could just write every single permutation out because it's a small number, but that would be very time inefficient. All right, so let's do one last example. In the description, I'll leave some worksheets I found online on permutations and combinations, and maybe you can attempt them if you feel like you're still not completely there with them. And if you need any help, then do let me know in the comments. But let's just do this last one, which I found personally a bit more challenging than the others. So, out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can we form? So we first need to identify, is it permutations or combinations? Looking at this, it could be combinations because you're choosing consonants and vowels, but then after that, it's number of words, and words are different depending on the arrangement of letters, so it suggests the permutations. Like you could have the word words, but you could also have with sword, or you can even have just sword. And these are all just different ways of using the same letters. So it is actually looking like it's a combination of permutations and combinations, which is actually the hardest part of doing this, because if we hadn't identified that, then we probably wouldn't have done the right working. Now we've identified it, it should become a lot easier. So let's start with the first step. We have to first find the ways 3 consonants and 2 vowels can be chosen. So that's the combination section of it. That means that we need to first do 7C3 times 4C2, which means which will allow us to see how many ways we can take 3 consonants and 2 vowels. So let's just input that into our calculator to see the exact number. All right, so we have 7C3, that's 35. Then we can multiply it by 4C2, which is equal to 210. So there are 210 ways of taking 3 consonants and 2 vowels from 7 consonants and 4 vowels. Now to the permutation side of it. So how many words can we make from the 3 consonants and 2 vowels that we have? Well, they're not giving us any restrictions in the order in which we place them at all. So that means we can take all 5 letters and put them in any way we want it. We can have the 3 consonants together, we can have a consonant, then a vowel, and then a consonant, then a vowel, and then a consonant. We can do it any way we like. So it doesn't really matter if it's a consonant or vowel anymore. That part has passed in the combination section. Now it's just 5p5, because we can put the letters any way we want. And 5p5 is the same as 5 factorial, because n in this case and r are the same. So 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is equal to 120. Well, now these two are still linked. These two values are linked by the same scenario, because it depends on which consonants you choose to give the different words. It's not like you're choosing these, but then there's another scenario where you can choose these. They're both in the same scenario, so it's multiplying by each other. So 210 times 120 is, for this one I'm going to need a calculator. It's not going to be so easy to just do mentally. 210 times 120 gives us 25,200. So our total number of values is 25,200. There are 25,200 different ways you can take 7 consonants and 4 vowels and make unique words. Okay, so let's recap by looking at some of the steps you can take to approach any permutations and combinations question. So, when you know it's permutations and combinations, step 1, identify if it is NPR or NCR. Sorry about my bad handwriting. After that, step 2, if it is NPR, then draw the box diagram with the number of slots, because each value has to be arranged in a specific way for it to be a unique permutation. Step 3, if it is NCR, then see the n. Remember, n is the number of values in total. And R is the values picked. And using this, identify the different scenarios. And as well as this, identify if work forwards or backwards. So what I mean by that is, do you look at the number of combinations where it doesn't work and then subtract it from the total number of combinations, or do you just take the number of combinations that do work? That depends on the speed at which you can attempt them. And then finally, evaluate with the calculator. And then you can, with your equations that you should have constructed in steps 2 and 3, you can finally get your final answer. And remember, if it's the same scenario, then equals times different scenario is adding up, and or subtracting if you're taking it away from the total number of scenarios. You usually won't do division, so I would ignore that for now. But other than that, these are the steps you can take to evaluate any permutations or combinations question. Even if it's both, then do steps 2 and 3. If not, then just do one or the other. Anyway, so thank you so much to all of you for watching. I'm going to drop a few worksheets in the description below that you can use to test your knowledge on permutations and combinations. If there's any specific question you'd like me to evaluate that doesn't actually like count as a whole topic, let me know and I'll still make a whole video on it, because it's probably going to be a question that most people would struggle on. And don't hesitate to ask me for any help otherwise. And yeah, in the other videos I'll also add some of the worksheets that you can use, but other than that, I think that's pretty much it. And so thank you so much for watching.